All right. Momentum.
A momentum problem that involves like more than the more than just what, I mean, of course, what we've talked about, but like that, like something that we can see on a quiz or something, like the complexity of what would be on a quiz.
So, like the homework problems.
Yeah.
I'm trying to think of homework problems. Oh, this is from the quiz from a previous book, I believe. Let me just double check that before yeah, it says chapter 6. A car of a mass of 1.6 megagrams is traveling east at 25 meters per second along a horizontal roadway. When its brakes are applied, the car stops in 6 seconds. What's the average horizontal force? Is that satisfied?
Is that momentum?
Yes, it is. Well, it can actually be solved with momentum, energy, or Newton's laws. And if I don't specify, choose whichever way your brain is working at that moment. So I have a car. Going this way, it has a mass of 1,600 kilograms, or 1.6 megagrams, going 25 meters per second. Brakes applied, and it stops in 6 seconds. Now, solving this using energy does not make a whole lot of sense, because energy is related to work, which deals with displacement, and I give you a time and not a displacement. If I told you the amount of, if I said it stopped at 100 meters, then work and energy might make more sense. But I gave you a time, so impulse and momentum make more sense. I know impulse is equal to the change in momentum. It's also equal to force times time, assuming force is constant. Change momentum, P final minus P initial, which is equal to force times time. And what's the formula for momentum? MV final minus MV initial. Well, let's figure out what our unknowns are to see if we need to bring in something else. Mass is given. Final velocity and initial velocity are given. And time is given. The only thing we don't have is force. So it becomes plug and chug at this point. So 1,600 times 25 minus, try that again. Final velocity is
0.
Yeah, 0 minus 1,600 times 25 is equal to that force times 6.
Would it be -6? Because you're going from, I was making initial time.
Until I get my time machine working, time goes forward. We will end up with a negative answer though for the force, because this is a vector, and if the car is going in the positive direction, as I implied right there, then, well, the brake's acting back.
Right.
So, doing the magic here, negative 1600 times 25 divided by 6.
Negative 6,666.666666.
6,600.
66.6666.
Well, that's a. Let's make sure we have more than 3 of them. Units?
Saying that newtons.
And if we wanted a positive answer?
Change we'd make that going this way negative.
Yep.
So then the 25 is negative, and then we can positive.
What is a megagram? Is it 1,000 grams or?
Kilo is 1,000, mega is 1,000,000.
So 1,000,000 grams.
Yeah, but we like kilograms, so it's 1,000 kilograms.
Now, could you have done?
The original problem was in kilograms.
Could you have done the problem with megagrams? Do you always is it purely for convenience sake? Or can I do these problems with any kind of convention?
If you had stuck with megagrams and this would have been 1.6, this would have been 6.666 repeating. And so this would become kilonewtons.
How would you know it would be kilonewtons?
Well, if I move the decimal point over 3 places that way, then the unit, so if I decrease the number by 1,000, this has to increase by 1,000. A factor of 1,000. That.
But Newton's default is kilograms?
Yes. Kilograms, meters, seconds. And just watch out for that. There are loads of problems that I will put in centimeters or something like that just because that's the way I'm thinking at that moment. In other ways, I'm gonna go, I wonder how many people will remember to put this in the right units. Questions?
Problem that we use one of the methods with.
Okay. Do you want an integer for an answer?
No.
Okay, then I will take the second question from this old quiz. 25 gram object moving to the right at 20 meters per second. Overtakes and has a perfectly elastic collision with a 10 gram object moving in the same direction at 15 meters per second. Find the velocity of each object after the collision. Now we'll start over here. So 25 grams going to the right at 20 meters per second. Gonna hit something else that is 10 grams going to the right at, I believe I said 15 meters per second.
So they're both going to the right, and the 25 gram one is like catching up.
Yes. For Mad Max fans. And if you don't understand that reference, yes, you haven't seen Mad Max, or it made no impression on you. collision problem, immediately you should think, oh, conservation momentum. Perfectly elastic collision, which is what I had spoken when I was reading out the problem. Perfectly elastic collision, you think, oh, I have 3 methods. So the question is, which method do you want to use? I heard somebody say 2, I think. Or somebody said, ooh. But, all right, so we'll use method 2. So I got my momentum here. I know M1 V1 plus M2 V2 is equal to initial equals M1 V final 1. And it really helps if I use the correct letters. V1 final plus M2 V2 final. Again, not a fan of all the subscripts I would have to write. So I'm just gonna go ahead and stick some numbers in here. 25, 20, plus 10, 15 is equal to 25C plus 10D. Now notice I did not change it into kilograms because I have grams across the board. If I put everything in kilograms, I'd have 0.025, 0.1, 0.025, and 0.1 here. But if I just multiplied everything by 1,000, I would end up with this. So mathematically, it really does not matter since I have grams on both sides of the equation.
Would you recommend, if we have one that's in grams and kilograms, going to convert the kilograms to grams or the grams to kilograms?
As general rule, I would say if you wanted a general rule, grams to kilograms. Always put it in kilograms. Now, method 2, we're also using the relative speed of approach as relative speed of recession. So it's the difference between the 2 before equals the reverse difference between the 2 after. So 20 minus 15. Since I did mass 1 first, over here I'll start with mass 2, D minus C. And so 2 equations, 2 unknowns. It's now a system of equations. There are oodles of way of solving that. I guess most common is to solve for an unknown in one of the equations, plug it to the other one. But it could also be done with graphs. It could also be done with matrices, Cramer's rule.
What was the
So-
third thing you said? Matrices?
Matrices.
Matrices.
Have you dealt with matrices?
Not, I think like once, but not.
Okay.
But that's when they're in the brackets and you have 1.
Yeah.
Different. 20. And how do we get 20 minus 15? Because wouldn't it be 20 plus 15? Because the 10 cancels out, the 25 cancel out.
No, these are not the same equation.
Oh.
This is for method 2, where we take, this is the relative speed of approach. In other words, from his point of view, he's coming at him at 5 meters per second. And then afterwards, from his point of view, he's going away at 5 meters per second.
Okay. And then D minus C is that.
That would be the relative speed of recession. That is, from the first mass's point of view, how fast is the second mass going after the collision? Are you good now?
Yeah.
So D is equal to C plus 5. Plugging to the first one. Oh, let's see. So that's 150 there. That's 500. So I have 650 equals 25C plus 10C plus 5. Substituting in. 650 is equal to 25C plus 10C plus 50. And when you're distributing, don't forget to distribute to both. Sometimes students just drop parentheses. So 650 is equal to 35C plus 50. 600 is equal to 35C, and C equals 22.14 meters per second. Oop. Nope, that's not right.
That's a lot.
Where's that?
17.14.
17.14 meters per second. And so D, that's the 22.
Now, you would just plug in the 17.14 back into the problem to solve for D.
Yeah, I mean, we have to really, we know what D is in terms of C right there.
So you just add,
Just add 5.
Can
Now-
you do this same situation using method 3?
Okay, you had another question?
With that, so we had the 20 minus 15, which was 5, equals D minus C,
Right.
which is also 5.
Well,
Oh, well, it would equal 5 because, yeah.
How would, sorry,
No, you're fine.
I think you answered your own
Yeah, I
question.
answered the question.
Okay.
how would that equation change if they were like going towards each other?
If they're going towards each other, then you'd be subtracting a negative number. Or it'd be a negative number minus a positive number.
What does that 5 represent? That we figured out?
Relative speed of approach. So if you're cruising along in your car at 50 miles per hour and someone behind you relative to the ground, and someone behind you is going 55 miles per hour, from your point of view, he's approaching you at 5 miles per hour.
But in this case, if we're box 2, I guess, the 10 kilogram one, and we're looking back at the other one, if we know the speeds of both boxes, can we not just subtract those and that's the answer? I know that's kind of what we did.
Yeah,
Is that what,
that is what we did.
okay.
So would you say method 2 is almost like solving the system of equations? Like in math, you have
Right.
solving system of equations, because you would have 2 equations and then you try to solve and then plug it in for the next.
Yeah, so are you asking about other methods of solving the same thing? I mean,
Yeah.
given the 2 equations?
Yeah.
Okay. So if you don't want to do substitution, we have 650 is equal to 35C plus,
It's 20.
oh wait, no, sorry. 25C plus 10D. Is that right? 650, okay. We can simplify this if you want to, just divide everything by 5, they're all multiples of 5. And so we get 130 is equal to 5C plus 2D, optional step. The other equation we have is 5 equals D minus C, or just to line them up, negative C plus D. When I add the 2 equations, I want to get rid of an unknown. So if I multiply this bottom equation by 5, I'll get a negative 5C here, and I'll have a positive 5C here. So I'll have the 130 is equal to 5C plus 2D. And then I'll have 25 is equal to negative 5C plus 5D. And then I just add them. So I get 155 over here, the C's will cancel out, and I'll have 7D.
Okay. Yeah.
I could have equally have multiplied this bottom equation by negative 2, and I would have gotten rid of the D's. Is that what you're?
Yeah.
Okay.
And then that gives us our D, and then we plug it back in to give us our C.
Yeah.
was that just solving D instead of C?
Yes. without doing substitution. Over there, we did substitution where we solved for an unknown and plugged in the other equation. This one, we multiplied one of the equations by a number so that when I just added them straight up, I would get rid of an unknown.
Can you, do,
Method 3?
yeah, no, yeah.
And for you matrix fans out there, 5, 2, -1, 1. For the matrix fans. All right. Sorry, light flashed to the matrix. All right. Method 3. First off, for method 3, we need to figure out how fast, if they were a perfectly inelastic collision, how fast would they be going? So I know my momentum was 650. And that's going to be equal to the total mass times V. So 650 over 35, which is
Then we got 35V from adding up
the two masses.
the two.
This is the perfectly inelastic collision. For method 3, you've got to do this step first. Because this is the velocity that you'll need to subtract from each of the initial velocities to bring the zero momentum frame.
Okay.
$46.6.
$18.57.